Hi, another little capa review for you here. This one from a couple of weeks ago, I guess, or no, a week ago. A set that was due on April 1st. Lots of titrations. This one was not a titration, a Ka problem from a pH. I think I'll leave that one for the moment. Good. Calculation of pHs. I know that maybe this was something to think about a little bit. Let's see what I got. Okay, you need to prepare a liter of half-molar phosphate buffer at a given pH. Okay, here's a liter. Always draw your picture. I find it helps a lot. We want to have 1 liter, and we want to have a quantity of, let me write the acid one first, the diprotic potassium phosphate and the monoprotic potassium phosphate, and we would like the pH of that to be 6.83. Okay, so the first thing we have to do is figure out the ratio of the two species. I guess that's the conjugate base. That would be the conjugate acid. It's given. There's a Kb given for that. That would be the pK2, phosphoric acid. So that pKa is 6.64. And so that should be pretty straightforward. If we remember Henderson-Hasselbalch, pH equals pKa plus log base over acid. And so that ratio, that's the base, that's the acid. That ratio is what we're after. So we should just be able to solve to substitute in 6.83 equals 6.64 plus log base over acid, if I can do it that way. And we'll have log base over acid equals 6.83 minus 6.64. So 0.19, and then we just need to take 10 to the power. We take the anti-log of that. So in my calculator, let me go second and hit 10 to the x. I'll go answer for that. So I get base over acid. I get that ratio. I get it as 1.5488, or as it's rounded, 1.55. So that looks good. Okay, now we know that we need to have the total phosphate concentration be 0.5 molar. So the 0.5 molar, we would like that to be the sum of the concentration of the diprotic and the monoprotic, those two. And we know that that's the ratio. So let me rewrite this. I'm just going to call this again A and B. So I have A over B equals 1.5488, and I also have another equation that tells me that 0.5 equals A plus B, and that's two equations with two unknowns, so I should be able to solve that. And we do this by multiplying through by A on this equation. Okay, so that gives me something I can substitute for B over here, so I can write 0.5 equals A plus 1 point, I'll just round this to 1.55. A plus 1.55a, so 0.5 equals 2.55a, or a equals 0.5 divided by 2.55. So a equals 0.196, and so b has to be 0.5. Oops, b has to be 0.5 minus that. So if I take that, 0.5, b should be 0.304 molar, and that nicely adds to 0.5. How many moles of each? Because I'm given 1 liter, and I want to have 0.19, because I'm supposed to shoot for 1 liter volume over here, right? That's my volume that I want to have. I need to have 0.196 moles of A in 1 liter. So that's going to be my number of moles of A is what? The acid form, the KH2PO4. It's got to then be 0.194 moles, because that divided by that 1 liter gets me my molar concentration. And that was my diprotic, my conjugate acid, my monoprotic has to be that many moles. Okay, and then I should be able to figure out the mass from the molar masses. So that should get you through that one. Okay, this is titration. No, this is figuring out the pH first. Do yourself a favor, draw a picture. Here's your aspirin. You have 0.005 molar of aspirin. That is a weak acid. It's acetyl salicylic acid. I'm just going to write it as H-asp for aspirin. Okay. So with that in solution, we have a weak acid. We have a weak acid equilibration problem. Reacting with water, and H3O plus. Okay, clean that up a little bit there. So we have an initial concentration here. We have I, C, and E. An initial concentration here. Again, that has to be in molar, 0 and 0. So we're going to use X, gain X. And do we have a Ka or a pKa? We have a Ka, and the Ka is the equilibrium constant for asp minus H3O plus over H-asp. And that is therefore going to be, 3 times 10 to the minus 4 equals X times X, so X squared. And X is going to be small, so we're going to drop that out. And that way I should be able to solve that one for X in the usual way, and I should be able to get the pH out of that. And let's see, I'm going to quit my video right here because I want to keep this under 10 minutes. So look for part 2 in a second.